We're asked to determine which table or tables represent linear functions or linear relationships. If a table represents a linear function, then the rate of change must be the same or a constant. To determine the rate of change in the table, we'll find the change in the function values and divide by the change in the x values. So what you'll notice here is finding the rate of change is the same as finding the slope between 2 points, because the slope does represent the rate of change for a linear function. So for each table, we'll determine the rate of change between these function values and x values, these function values and x values, and these function values and x values. And we'll do the same for each table. And again, this is the same as finding the slope between 2 points. So to find this first rate of change, we'll find the difference of the function values. So 7 minus 1 would be 6. And we'll divide this by the change in the x values. 2 minus 0 is 2. So the rate of change is 3, which would also be the slope between these 2 points. For this next set, the change in the function values will be 9 minus 7, that's 2. And the change in the x values would be 3 minus 2, that's 1. Well, here the rate of change is 2. Well, 2 doesn't equal 3. Therefore, this table does not represent a linear function. But let's go ahead and find the rate of change between these function values and these x values. So we'd have 16 minus 9, that's 7. And 5 minus 3 is 2. 7 halves is equal to 3.5. Again, because the rate of changes are not the same, this is not a linear function. Now we'll go ahead and do the same for the next 2 tables. So we'll find the rate of change here, here, and here. So negative 7 minus negative 3 is going to be negative 4. And then 3 minus 1 is equal to 2. So the rate of change here is negative 2. Next we have negative 15 minus negative 7, or negative 15 plus 7, that's negative 8. Divided by 7 minus 3, that's 4. Negative 8 divided by 4 is still negative 2. The rate of change is the same so far. Next, the change in the function values will be negative 17 minus negative 15, that's negative 2. And the change of x would be 8 minus 7, which is equal to 1. Notice in this table, the rate of change is constant, or we can say the slope between these points is always negative 2. Therefore, this table does represent a linear function. We have one more table to check. So we'll determine the rate of change here, here, and here. Again, the change in the function values would be 2 minus 1, that's 1. The change in the x values, 3 minus 0 is 3. Rate of change is 1/3 here. Next we have 3 minus 2, that's 1. And then we have 6 minus 3, that's 3. Rate of change is 1/3 here as well. And then one more time we have the change in the function values, 4 minus 3 is 1. And the change in the x values, 9 minus 6 is equal to 3. Again, notice how the rate of change is constant, where the slope between the points is always 1/3. Therefore, this table also represents a linear function. So the second table and the third table both represent linear functions.